Math 1332, Chapter 3, Symbolic Logic, Section 5, Euler Circles, Video 2, Euler Circles for Types of Statements. In the previous video, we learned about the types of statements that we would be using in different types of arguments, namely quantified statements. And we identified those statements as universal positive, universal negative, universal affirmative, universal negative, particular affirmative, and particular negative. In this video, we're going to learn how to draw pictures for each of those types of quantified statements. Let's start with the universal affirmative. Just a reminder, a universal affirmative says that all of one group of objects belongs to another group of objects. For example, consider the universal affirmative, all eagles have wings. This statement says that all eagles belong to the group of all things with wings. Now you might start thinking this is sounding a little bit like the set theory stuff that we talked about in chapter 2, and you would be correct because after all, Euler circles are pretty much Venn diagrams which are associated with sets. So we need to think about these statements in the context of set theory. From a set theory perspective, this is like saying that the set of eagles is a subset of the set of things with wings. For example, if you think of a room and inside that room we put everything that has wings, that all of the eagles would have to be in there. There would be other creatures and things in there as well, but the set of eagles would be inside the set of things with wings. As such, from a Venn diagram perspective, we can draw the set of eagles inside the set of things with wings. Now, I don't have the Venn diagram drawn yet because I want you to witness me actually drawing this Venn diagram. It's not that hard to do. We want to show that the set of eagles is inside the set of things with wings. So let's start by drawing a big set, and that will be the set for the set of things with wings. So we'll put this right here. And to show that the set of all eagles belongs inside of there, we'll draw another set inside of the things with wings, and that will be the set for eagles. By drawing the circle for eagles inside the set of things with wings, we're showing that all eagles have wings. This is how you draw an Euler circle for a universal affirmative, a Venn diagram for subsets, one set inside of another. The universal negative says one group of objects has nothing in common with another group of objects. For example, consider the universal negative, no dogs have wings. This statement says that the set of dogs has nothing in common with the set of things with wings. Now think about how we could illustrate this in a Venn diagram. If we had a circle for a set of dogs and the circle for the set of things with wings, how could we draw it so that we show that they have nothing in common? From a set theory perspective, this is like saying the set of dogs is disjoint from the set of things with wings. Remember, two sets are disjoint if they have nothing in common. As such, from a Venn diagram perspective, we can draw the set of dogs and the set of things with wings with no intersection. Again, I want you to witness me drawing this because you will be drawing some Euler circles. To show that no dogs have wings, we'll draw a set for dogs. So we'll label this one dogs. And we'll draw another set for things with wings. But we can't overlap the dog circle because if we did, we're saying that there are some things that belong to both sets simultaneously. Those things would be dogs with wings. This is how you draw an Euler circle for a universal negative, disjoint sets with no intersection. So to contrast the two, universal affirmative, one circle inside of another, universal negative, no overlap whatsoever. Now let's move to the particulars, which state the existence of an object that does or does not have a characteristic. For the particular affirmative, a particular affirmative says that at least one in a group of objects also belongs to another group of objects. For example, consider the particular affirmative, some birds are yellow. Missing a period there, but I don't care. This statement says that there is an object in the set of birds that also belongs to the set of yellow things. Now, before we get to the Venn diagram, let's think about this. A particular affirmative is not talking about an entire group of objects, but rather a single thing inside that group of objects. From a set theory perspective, a particular affirmative is not talking about an entire set, but the existence of an element inside that set. So our picture has to be kind of at the element level. From a set theory perspective, this is like saying there is an element in the intersection of the set of birds and the set of yellow things. As such, from a Venn diagram perspective, we can draw the set of birds intersecting the set of yellow things and indicate the existence of a common element by marking an X in the intersection. Again, I'm going to draw the Venn diagram so that you can see it come to fruition. We want to show some birds are yellow. So we're going to start by drawing a circle for birds, maybe. Why is this not drawing? There we go. Let's move this over a little bit. And then another circle for yellow things. Let's go ahead and label these. Birds, yellow things. But to show the existence of an element that has that belongs to both sets, an element that is both a bird and yellow, we put an X in the intersection to say there's at least one thing that's common to both circles, at least one thing that is both a bird and yellow, aka a yellow bird. So there is some bird that is yellow. This is how you draw an Euler circle for a particular affirmative. Indicate the existence of an element in the overlap, and really that should say intersection, but we'll leave it that way. But you indicate the existence of an element with an X. And finally, the particular negative. A particular negative says that at least one in a group of objects does not belong to another group of objects. For example, consider the particular negative, some birds are not yellow. This statement says there is an object in the set of birds that does not belong to the set of yellow things. Now let's think about this from a Venn diagram perspective for a moment. We're going to have a circle representing birds and a circle representing yellow things, which can still have an overlap. But we're stating that there is a bird that is not yellow. So where do you think we would put an X to represent that bird? From a set theory perspective, this is like saying there is an element in the set of birds that is simultaneously outside the set of yellow things. As such, from a Venn diagram perspective, we can draw the set of birds intersecting the set of yellow things and indicate the existence of an element inside the set of birds, but outside the set of yellow things. In other words, in the set bird minus yellow things. We can indicate the existence of that object with an X. So again, we're going to draw the Venn diagram live so that you can see it being drawn. We start with a circle for birds and a circle for yellow things. And we go ahead and overlap them, even though we're not necessarily saying that there exists something in the overlap. But unless you know for sure that two sets have nothing in common, you have to draw an intersection. The only time you can get away with not drawing an intersection, in other words, with not having them overlap, is when you know specifically they have nothing in common, as in the case with the universal negative. But to show the existence of a bird that's not yellow, this X representing a single element, in this case a bird, has to be in the bird circle, but outside of the yellow thing circle right there. And so, this is how you draw an Euler circle for a particular negative. Indicate the existence of an element in the first set, but outside the second set with an X. So let's quickly summarize the four types of Euler circle Venn diagrams. The universal positive is for a statement of the form, all A are B. And the Euler circle is a circle A inside of circle B, meaning that everything in A simultaneously belongs to B. For the universal negative, and let's highlight these as we talk about them. So there's the universal positive we just talked about. For the universal negative, a statement of the form no A are B we have to illustrate that there is nothing in common to sets A and B, which we show with two disjoint circles, two circles that do not intersect. For the particular positive, a statement of the form some A are B, we have to show the existence of an element in the intersection. So we draw both circles with an overlap, put an X in the middle to indicate that there is something in here. There is something that belongs to A that also belongs to B. And for the particular negative, some A are not B, we still draw the two overlapping circles because we don't have evidence that they don't have anything in common, so we can't assume that they don't. If they didn't, the intersection would just be empty. But to show that there is some A that is not B, some A that are not B, we can show the existence of such an element by putting an X inside the A circle but outside the B circle.